Okay, you guys will have to bear with my voice a little bit here today. Sorry about that. We're doing 6.6.4 today, triangle midsegment theorem. And it's just another segment inside the triangle. However, it's not like the other four that we've learned where there's a point of concurrency in the middle. It's a little bit different than that. So it's a little, we just go over it separate from those three. So learning goals are to learn what a midsegment is and then use the midsegment theorem to find some distances. So first of all, it says the midsegment of a triangle connects the midpoints of two sides of the triangle. So you have a triangle where every one of them has three midsegments. You can see there that MN, MP, and NP are all midsegments of that triangle because they're connecting the midpoints, and we have that notation on the triangle. So the first thing we're going to do here is actually kind of going to help us figure out what a midsegment is and what it gives us. So it says in triangle JKL, show that the midsegment is parallel to JL and that MN is 1/2 JL. So what we're going to do is first of all prove that they're parallel. In order to do that, we're going to find the slope. So M, the coordinate point, it looks like is at -4, 3. And then N is at 0, 2. So we're going to find the slope of MN, and that is 3 minus 2 over -4 minus 0, which gives us 1 over -4. So our slope of the midsegment is -1/4. So now what we're going to do is we're going to look at the base that's parallel to it and make sure that it's parallel. So the base that's parallel is JL, and again, we have J is at -6, -1, or excuse me, -6, 1, and L is at 2, -1. So if we find the slope, we have 1 minus -1 over -6 minus 2, which is 2 over -8, and that reduces to -1/4. So that part checks out. Now, in order to show it's half as long, what we need to do is find the distance. Again, just a reminder, the distance formula, in case you don't have it in your notes, is x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So when we do the distance of the first one, we have -4 plus 0 quantity squared plus 3 minus 2 quantity squared. And I put plus 0. You could just as easily have put minus 0. It doesn't matter. So -4 squared plus 1 squared. And that gives us 16 plus 1, which is the square root of 17. And I'm just going to leave it like that. Now, you could punch it in a calculator, and that's fine. But I'm going to leave it the square root of 17. And we're going to re-go over how to simplify radicals. So the distance of JL is going to be -6 minus 2 quantity squared plus 1 minus -1 quantity squared. And again, that's all underneath the square root symbol. So when we do this, we get -8 squared plus 2 squared, which is 64, plus, pardon my alarm, sorry, which is 64 plus 4. And if we take the square root of 68, when we go to ladder that out, 2 goes in 34 times, 2 goes in again 17 times, and 17 goes in once. So when I'm simplifying the square root of 68, it simplifies down to 2 times the square root of 17. So we can see that it's literally twice as much as that square root of 17. So that's proving what we get when we have a midsegment. Go ahead and try this. Pause. Again, really, this is the only one that requires us to do a whole lot of math. The rest of them, it's just taking it times 2 or divided by 2. So take the opportunity real quick to try this, but I'm just going to zoom out on this and show you the answer. So again, pause if you haven't done it yet. Okay, so you can see there, they're parallel. They're both 3/2, and the DE segment is the square root of 13, and the other segment is 2 times the square root of 13 after we simplify. So now in our notes, we are given the fact that any midsegment is going to, 1, be parallel to the base that it's across. So this and this are parallel, and it's half the length forever and ever. All right, so in this problem, it says we have some roof trusses, and it says we want to find the lengths of these midsegments. So if you look at here, it says that UV and VW are midsegments. So we can mark those right there. There's the UV and VW are the midsegments. And we want to find U, V, and RS. So in this triangle, we are given the fact that RT down here is 90. We know that UV is half that, so UV has to be 45 inches. And then RS is also, again, the parallel side to the 57. So we have to take 57 times 2, and we get 114 inches. Now, the other thing that's kind of useful to us is that UV and RW and RT are going to have to be the same length. So we essentially have kind of a mini parallelogram in here that we'll use at times that helps us out because those sides are congruent. Again, it's kind of busy, so I just put the solution here. It says in a kaleidoscope image, AE and BE, and then our A and BE are congruent, AD and CD are congruent, show that they're parallel. Again, I just kind of put this in there so you can see it. You would just prove that they're parallel using the slopes and say that they're half the length. So we're not going to worry so much about that. Again, pardon me, when we have some story problems like this in our homework, we just look for things where it tells us what are midsegments. In this one, it says we have midpoints at Peach Street and Cherry Street. So this is the midpoint, this is the midpoint. So these segments are equal. But really what that gives us is that this Peach Street is the midsegment to this little cul-de-sac, and it's going to be half the length of Plum Street, which is 0.7. So the midsegments are pretty straightforward. I'll go ahead and post your guys' work. Practice it. You'll have a work day tomorrow. Please make sure you're staying on top of your stuff. As far as those mid-chapter quizzes go, the likelihood that those go in the grade book is probably pretty slim. We're probably going to go over some stuff together and fix those or retake them all together once I'm able to come back and grade those. All right, thank you so much, guys. Have a good day.